Hello geometry scholars! Today we're going to be discussing how to find the area of different types of quadrilaterals. Now before we begin, as per usual, please make sure you have your notes or at least a blank sheet of paper to write some notes down onto, something to write with, and a calculator. So let's go ahead and get started on area for different types of quadrilaterals. Now this particular video we are focusing on specifically the parallelogram quadrilaterals. So what is a parallelogram? A parallelogram is a quadrilateral, a four-sided figure, 1, 2, 3, 4, that has both pair of opposite sides parallel. So notice that the top and the bottom are parallel to each other, and the left and the right-hand sides are parallel to each other. We notate our parallelogram with a small parallelogram symbol, and then we list out the letters of the four vertices of our parallelogram. So we could call this parallelogram P, Q, R, S. Now the area formula for a parallelogram is always going to be base times height, just like with a rectangle. But do be careful. The base and the height must be perpendicular. They must be at right angles with each other. So this is different than in a rectangle in that the height and the base may not necessarily be the sides of our figure. Notice that the height is the distance between the top and the bottom. It's not necessarily this side of the parallelogram. So do be careful when you plug in your numbers. Make sure you're plugging in the numbers for the values of the lengths that are perpendicular. The next parallelogram we're going to discuss is the rhombus. Again, it's a parallelogram, so it is a quadrilateral. It has 1, 2, 3, 4 sides. It has both pair of opposite sides parallel, top, bottom, left, right, but it also has 4 congruent sides. All 4 of the sides must be the same length. The most common rhombus that you're probably familiar with is, in fact, the square. Now, since a rhombus is a type of parallelogram, the area for the parallelogram formula will also apply to the rhombus. So there will be some cases where we want to use this A equals B times H formula in order to find our area. However, there's a secondary formula that applies only to the rhombus. This is 1/2 times the length of diagonal 1 times the length of diagonal 2. So whatever the lengths of these diagonals are, can also be helpful in helping us find the area. We can plug those numbers in, multiply them together, and divide by 2. All right, let's try a couple of examples. Example 1 tells us we have a parallelogram. Recall that our area for a parallelogram is just base times height, where the base and height are perpendicular segments. So our height here is 32, and our base is 42. So let's plug those values in. 42 times 32. We can use our calculator and get a value. It looks like the area of this particular parallelogram is 1,344 square inches. Remember that area is a unit of square units. It's always to the second power. So if you're given a unit, inches, centimeters, feet, whatever, make sure that that unit is squared when we write the area. Next one, again, another parallelogram here. Again, our area formula is base times height. However, notice that we are missing the height. We have the base, because in a parallelogram, the top and the bottom are congruent. So if this is a 9, this is also a 9 down here on the base. But this 6 is not the height. This is a side of the parallelogram. We have to find the height. What they've given us, though, is this angle. And what we can do is use our trigonometry, those sine, cosine, and tangent functions, to help us solve for the height. All right, so let's think back. Sine, cosine, and tangents. If we have the side opposite the angle, and we have the hypotenuse, so opposite and hypotenuse, which function will we use? Sine, cosine, or tangent? Hopefully you said sine. Sine of the angle is equal to the side length opposite divided by the hypotenuse of the triangle. So we can solve this equation. Sine of 35 equals h over 6. Let's multiply by 6 on both sides to get h by itself. And again, we can utilize our calculator to find our h value. So the height of this parallelogram and this triangle should be approximately 3.4 centimeters. Now that we have our height, we can find the area of our parallelogram. Area equals base, which is 9, times the height that we found to be 3.4. So 9 times 3.4, approximately 30.6 square centimeters. The next problem asks us to find the area of the rhombus. Now our formula for the area of a rhombus is 1/2 the length of the first diagonal times the length of the second diagonal. So looking at our diagram, one diagonal is a length of 11, the other is a length of 10. So all we need to do is plug in those values and solve. It doesn't matter which is the first diagonal and which is the second. Since this is multiplication, the order is not important. We could do 10 times 11 or 11 times 10, and we'll still get the same answer. So let's check it out. 1/2 times 11 times 10. The area for this rhombus should be about 55 square units. Example 4. This one is also a rhombus, but notice we aren't given the diagonals on this one. So this formula, d1 times d2 times 1/2, is not going to be as useful for us. But do recall that a rhombus is in fact a parallelogram. So we can use this formula, b times h. We simply need to figure out what is the base and what is the height. Well, since a rhombus has all of its sides congruent, we know that this 14 is going to be the base length. To find the height, again, we've got a triangle to solve. So we can think back to our trigonometry once again. In this triangle, we have a 45-degree angle. We know the side opposite is h, and we know the length of the hypotenuse is 14. This 14 down here is not helpful for the triangle because this 14 is the entire length. It's not the length of the triangle, it's the entire length of the rhombus. So we just want to isolate to the h and this 14. So once again, let's think back. Sine, cosine, or tangent. We have the side opposite and the hypotenuse. Hopefully you said sine. If we take sine of 45 degrees, that will equal the length of the opposite side, h, divided by the hypotenuse, 14. Let's solve the equation. We'll multiply by 14 on both sides and use our calculator to solve. The height of this triangle and the height of the rhombus should be approximately 9.9. Now that we have the height, and since it's a rhombus, we know all the sides are the same, so we also have the base. So we can use our formula, base times height, to find the area. So the area of this rhombus, which is also a parallelogram, is approximately 138.6. The last problem we're going to discuss today involves another rhombus. This one tells us that AC, this length, is a length of 20. It also tells us that BD, this length, is a length of 15. We're also given in the diagram that the height, so the distance from the top to the bottom, is a length of 12. We're also given that the length of each side is 12.5. It tells us we can find the area of this rhombus in more than one way. You want to fill in the blanks to figure out which ways to find the area, and then calculate those blanks by multiplying them together to find the area. So take a minute, see if you can figure this out. What values go in the blanks, and what should the area be? Think about the different ways that you can calculate the area for a rhombus. Pause the video, try it now. Alright guys, you've had a moment, let's see how you did. First one, A equals blank times 12. Well, 12, hopefully you notice 12 is the height of our rhombus. So thinking about our area formulas, which one uses height? Hopefully you came up with the area for a parallelogram, where we take base times height. So the base length of the rhombus is actually 12.5. So 12 times 12.5, 150 square units. So that's our area for a parallelogram formula. Okay, part B. 1/2 times blank times blank. Again, let's think about our possibilities for finding the area of a rhombus. What formula uses the 1/2? Hopefully you said the 1/2 times diagonal 1 times diagonal 2, where our diagonals in this case are 20 and 15. So again, let's take 1/2 times 20 times 15, 150. So using the area of a rhombus formula, we get the same result. So once again, this validates the fact that a rhombus, its area can be found in multiple ways. We could use the parallelogram formula or the rhombus formula. You simply need to look at what information is given. If you know both diagonals, use the rhombus formula. If you know the base and the height, use the parallelogram formula. If you know all of that information, take your pick. Use whichever one works best for you. All right, folks, that takes care of our work today on the area of parallelograms.